China has made history successfully landing on what has been up until now the unexplored far side of the moon.
China has managed to bring moon rocks back to Earth, first mission to do so in over 40 years.
For decades after the Apollo and Luna missions, the moon remained a silent, distant world, while humanity turned its attention to Mars and beyond. The last samples brought back by the Soviet Union in 1976 marked the end of an era. For nearly half a century, no nation returned to explore its surface. But in the 21st century, the moon quietly became the focus of a new space race. China, the United States, India, and private companies like SpaceX reignited lunar ambitions. NASA developed the Artemis program, aiming to return astronauts to the moon by the late 2020s. SpaceX designed reusable rockets, while India sent its own robotic explorers. Yet it was China that quietly pushed into territory no human or robot had ever reached, the far side of the moon. The discoveries made by the China National Space Administration may change not only our understanding of the moon, but the future of energy, science, and space exploration itself. China's lunar program began in the 2000s with a clear goal: to become a major space power. Unlike the hurried race of the Cold War, China's approach was methodical, step by step, and long-term. Each mission built on the previous one, forming a roadmap of progress that could not easily be reversed. The program was named after Chang'e, the ancient Chinese moon goddess, with each spacecraft representing a chapter in this story. In 2007, Chang'e 1 became China's first lunar orbiter. It mapped the moon in 3 dimensions, analyzing soil composition and surface contours. Among its findings was an early hint of helium-3, a rare isotope on Earth but abundant in lunar soil. Helium-3 has the potential to fuel nuclear fusion reactors, providing immense clean energy with almost no radioactive waste. This discovery hinted that China's lunar ambitions were not only scientific, but also strategic. 3 years later, Chang'e 2 launched with higher resolution instruments, flying just 15 kilometers above the surface to map potential landing sites for future rovers. Its goal was to prepare for the first soft landing on the moon in more than 3 decades. Then came Chang'e 3 in 2013, which achieved a historic soft landing on the near side in Mare Imbrium. Deploying the U2 rover U2 carried the first ultraviolet telescope on the moon, opening a window to the cosmos free from Earth's atmospheric interference. The real breakthrough came in 2019 with Chang'e 4, designed to explore the moon's far side, a hemisphere that always faces away from Earth and had never been visited. This region is permanently hidden from direct radio contact, requiring a relay satellite to communicate with Earth. China launched Queqiao, the Magpie Bridge, positioned at the Earth-Moon L2 point. From this vantage, it could see both the far side and Earth, serving as a critical communication link. On January 3, 2019, Chang'e 4 touched down inside the Von Karman crater within the colossal South Pole Aitken Basin, one of the largest impact structures in the solar system. The landing was unprecedented. No nation had ever explored this area. U2-2, the rover, rolled onto the Gray Plains, capturing images and analyzing terrain that no human eye had seen up close. The far side is geologically distinct, with a thicker crust, heavily cratered surfaces, and almost no dark lava seas like the near side. U2-2 began collecting data that could finally explain why the moon's 2 faces differ so dramatically. China's lunar missions uncovered multiple surprising findings. The soil contains helium-3, which could power future nuclear fusion reactors. The Chang'e 5 mission in 2020 returned 1.7 kilograms of lunar rocks and soil, including a new mineral named Change Site Y containing traces of helium-3. Just 1.4 ounces of this isotope could produce as much energy as 5,000 tons of coal. Estimates suggest over 1 million tons of helium-3 exists in the lunar regolith, enough to power Earth for thousands of years. Yet not all discoveries were expected. In 2019, U2-2 spotted a shiny, glassy patch inside a small crater. Initially speculated to be alien material or lunar liquid, it turned out to be breccia, rocks fused into glass by meteorite impacts, rich in minerals like olivine and pyroxene. Later, in 2021, the rover captured a cube-shaped silhouette on the horizon. Nicknamed the Mystery Hut, internet speculation suggested it could be alien or artificial, but as the rover approached, it was revealed to be an unusually shaped boulder, resembling a crouching rabbit, a fitting nod to U2 itself. Chang'e 4 also carried out a small biosphere experiment, a container with cotton seeds, potato seeds, yeast, and fruit fly eggs. In January 2019, a cotton seed sprouted, the first plant in human history to grow on another celestial body. The sprout lived only a few days before lunar night arrived and temperatures dropped to -62 degrees Fahrenheit. Still, the experiment proved that biological growth is possible in lunar gravity, paving the way for future greenhouses on the moon. China's discoveries have implications far beyond science. The far side's radio silence makes it an ideal location for telescopes shielded from Earth's interference. Confirmed deposits of helium-3 and other minerals suggest a future lunar mining industry. Water ice, found in permanently shadowed craters near the poles, could provide drinking water and fuel, split into hydrogen and oxygen. Using in situ resources, astronauts could sustain life on the moon without constant resupply from Earth. Looking forward, the Chang'e 7 and 8 missions, planned for the late 2020s, will explore the moon's southern polar regions. Chang'e 7 will search for water ice and study the polar environment using a lander, rover, and small hopping probes. Chang'e 8 will test 3D printing using lunar soil, preparing for construction of the International Lunar Research Station, a permanent base envisioned by China and Russia in the 2030s. This base will operate outside the US-led Artemis Accords, signaling a new chapter in international lunar cooperation and competition. Meanwhile, the United States is pushing forward with NASA's Artemis program, aiming to return humans to the moon's south pole and establish a permanent presence. Artemis 3, originally scheduled for 2024, is now expected around 2027. SpaceX and Blue Origin are supporting these missions, highlighting a renewed lunar competition. In 2024, China officially acknowledged the US as a competitor in the moon race. Strategic reports foresee China's ILRS and the US Artemis base operating side by side, competing for sunlit ridgelines and proximity to ice deposits, resources critical for sustained lunar habitation. This new space race is not about flags or footprints, as in the 1960s. Today, it revolves around resources, technology, and strategic influence. Helium-3 could revolutionize energy production. Lunar water could fuel rockets for Mars and beyond. Whoever develops the technology first will gain immense geopolitical and economic power. Legal frameworks like the 1967 Outer Space Treaty prevent sovereignty claims, but they do not regulate resource extraction. The US and its allies follow the Artemis Accords, while China and Russia chart a separate path, challenging international norms. China's methodical approach demonstrates that the moon is no longer a static, barren world. Its far side, once a mystery, is now a laboratory, a proving ground, and a potential hub for humanity's future. The discoveries of helium-3, ancient minerals, impact-formed glass, and the first plant grown on another world are reshaping our understanding of the moon and preparing for a new era of permanent human presence beyond Earth. Half a century ago, the moon race was about speed and competition. Today, it is about strategy, technology, and survival. The moon is no longer a silent, untouchable world. It is a frontier where nations are laying the foundation for energy, exploration, and civilization itself. The question is no longer if we will return, but who will stay, and what secrets will they uncover on this silver orb orbiting above our heads.